Well, at the outset, absolute pleasure to be here. Thank you everybody for joining. I will share my screen and we'll go through a few slides quickly just to set the context for what we're going to do today, and then we'll dive into the code. This is going to be a hands-on approach, and you're very welcome and warmly invited to code along with me. Yulia, you need to let me share my screen, please.
Yeah, I will do it. And meanwhile, I'm doing it. Maybe you can also share with our participants a little bit about yourself, your background. I think it will be very interesting to hear your story.
Absolutely, I will do that. I was going to do that using the slides, but sure. Yeah.
I will give you the rights now. I think you can share your screen. Try it now.
Yeah, now I think it's going to work. Yeah. Is my screen visible?
Yes.
Perfect. Thank you. Thank you so much. All right. So welcome to day 3, everybody, to our event, Big Revolution in Tiny Machine Learning. Today's event is going to be about productionalizing machine learning or artificial intelligence for front-end applications. At the outset, I would like to thank Learning.DAY and all the other organizers for organizing a wonderful event packed with information, packed with content, and it's an absolute honor to speak here. Also, thanks to Soham and Anu for their constant support, and to all the other speakers for setting the stage and making it a very, very competitive space. I'm anxious about presenting and living up to the standards of the event so far. A few words about me before we begin. I studied in Bonn. I did a PhD in computational chemistry, after which I moved into the data field. I started in a company called Heartbeat Labs, which was a digital healthcare platform. I worked as a data engineer there for 2 years, and then moved as a data scientist into the data engineering department of a strategy consulting firm called Athenium, where I'm presently based. Athenium is a knowledge sharing platform. They're into strategy consulting and global business intelligence. I work personally on the interface between data science and data engineering. So that basically spans the entire data pipeline. And this is exactly what I want to share with you today. So we've already seen how edge AI and how tiny machine learning is a very versatile field where there are people from all disciplines having something to contribute. This was highlighted by Blair Newman very nicely. And true to that spirit, I would like to add a new dimension to this workflow, which is the data engineering approach. Yesterday's event was about machine learning, about building models. Today's event is actually going to be about productionalizing these models. So what can you do with it? What happens under the hood in a platform like Learning.DAY? What is going on? How do you actually bring a model to life? In order to make the process a little bit more instructive and interesting, I've split my tutorial today into 3 parts. In the first part, I'm going to talk about Flask, which is a web application framework. It's a micro framework based in Python. We're going to talk about some Flask basics, but mainly by way of demonstration. This is not going to be a theory lesson. We're going to talk about endpoints, URLs, how to integrate HTMLs, and how to make API endpoints, application programming interface. You're going to see in a moment what that is. Then we're going to talk about machine learning APIs. We're going to do this for the IRIS dataset, which is a commonly studied dataset about flowers. And basically, I'm going to show you how you can take a model and convert this into an API. And then, of course, we're going to extend this to the classification dataset that was demonstrated yesterday. We're going to make an API out of that and try and extend that to a website. We'll see how far we get. This stuff can be quite involved. So we will see. And the last part is going to be about Streamlit, which is a web application framework based in Python. But Streamlit is newer, and it takes much of the web development hassle out of the picture, which allows you to bring your web apps to life very quickly. So we're going to experiment a little bit with Streamlit and once again try and bring yesterday's data set into a web app setting. For you, the best way that I'd like you to follow is by coding along. because this is going to be a learning by doing approach. Today's presentation is not a theory-based event. I'm going to start coding, and I think you'd find the most value if you coded along. I'd be genuinely happy. But if this is not possible, I have put the repo here, and I will share this link in the chat in a minute. You can go to this repo, you can clone it, and you can also follow along. This might be a good idea in case my screen is not visible clearly enough, or the font is not big. This might help you. I like to begin events like this by clearly stating learning outcomes so that the expectations are set clearly right at the outset. And in this regard, I'd like to say that in the next hour or an hour and a couple of minutes, we'll basically talk about the basics of web app programming. So APIs with Flask, integration of machine learning into the workflow, and then we'll see how Streamlit makes life easy. What do you need to do? Well, if you could clone the repo, this would be great. But in general, just code along. This is a learning by doing approach. And feel free to ask as many questions as you like. I will stop and answer, and then we will just see how far we get. For a little bit more context, this is the Flask framework. You're welcome to look it up. This is basically web development, one drop at a time. And we're going to use the Flask framework to build some stuff. And then we're going to talk about Streamlit, which is new. Streamlit is claimed to be the fastest way to build and share data apps, which takes much of the API and the web development out of the picture because that happens under the hood. It's still happening. It's just that the user doesn't need to do this. Streamlit is a new library, and I'm a big fan of Streamlit. And I thought that no web app, no front end machine learning event, should happen without Streamlit being mentioned. All right. With this, I'm going to switch to my code editor, and we can get started. If there are any questions, then please go ahead and ask me, and I'll be happy to answer them. Let me try and share the GitHub repo in the link, in the chat window, I mean. Here you go. This is the GitHub repo. Please feel free to clone this, and you can use this to follow along or code from scratch. I'm going to code from scratch, and we'll see how far we get. Any questions, any clarifications, any problems with accessing the repo, please do let me know. All right. Since I don't see anything in the chat window, I'm going to assume that there are no questions and that you're able to access the repository. So let's get started now then with some basics. So as you can see, if you clone the repo, you will see that there are two folders here, and they're called Streamlit and Flask tutorial. We will start with the Flask tutorial. So if you go into Flask tutorial, you will see that there's Flask basics, and then there's an iris data set and a classification data set. We'll talk about some basics, see how we can, write some simple Flask applications, and then we will try and extend this, to machine learning and see how far we can get. All right, let's get started. So to write a Flask program, the first thing that you need to do is you need to, of course, import Flask. So you import Flask and you import the render template module from Flask. For this, of course, you have to have Flask installed. If this is not the case, you can do it with pip install Flask should enable you to have all the Flask modules that you need. For me, it's already installed, and so I will go on from here. So what is happening here is we are importing the Flask module in the project. This is mandatory, and it's an object of Flask class for our application. Having done this, we're going to now take the Flask constructor so that it can take in the name of the current module as argument. So we are going to say app is Flask, and then all right. So now, since this is done, we have now created the constructor, the Flask constructor. We can go ahead and define our roots. So what is a root? The root function of the Flask class is a decorator, which simply tells our application how to map a URL to the associated function. So what I'm going to do is I'm going to say app.root. And this is basically all that you really need for a Flask program in its simplest form. So you say this, and that's it. Now, this URL is going to be bound with everything that I do afterwards. So now I can define my function. So I can say def hello world. And I can return something. I can say return hello world. So this function is now going to return this string, and this is going to simply be routed to this URL. So let's look at this. Nothing impressive, but very fundamental and basic to every program. Sorry? Is there a question?
Promit, just increase your font. We are not able to see it clearly.
Sure.
Yeah, that's it. Sorry.
Is it better now?
A bit more.
Sure.
Yeah, much better.
All right, and I will put this down, and I can move this to the side.
Yeah, much better.
All right, perfect. Please feel free to mute and ask questions because I'm not looking at the chat window. So if there are questions, just interrupt me and ask. Since this is a live coding program, the faster you ask, the better it is for you to follow. All right. So this ran without an error. So basically, what we can now do is this is the standard, Pythonic approach. What do? We say app.run, and that's it. And now when you run this, you will see that this runs on localhost with this port. And it is possible to now follow this here, and you see hello world being rendered to this URL. So this is a very basic hello world web app where Python is actually hosting this application, and it runs on our local host on this port. As simple as that. From here, it's very easy to scale up, and this is exactly what we're going to do. So we're going to start now by trying to add a few more roots. So let's start by making some variable roots to begin with. Then we'll get into HTMLs, and then from there we will go into a little bit more complicated stuff, and then finally into APIs. So let me now define a root that will take a word and capitalize it, for example. So this here basically tells Flask that this is a placeholder. So this is a variable, and this basically allows me to have dynamic roots. I'll show you in a minute. So here I'm trying to capitalize. So basically I have to put this in my function. So I can just say return, and I can, put this into HTML tag because it's a web page after all. And I can just say that, and here I can say take the word and then just capitalize it using capitalize. It is not defined because I have not defined my function. So I have to say it F capitalize. So what is happening here is now I've tried to build a root, which is basically going to take a word and capitalize it. Let's try and see this in action. So what I have to do is I have to stop running this, and now if your application is already running on your port, you would either have to kill it or run it on a new port. So what I will do is I will kill it and make sure that I have no Flask instances running, after which I will now run my program again. And now if I go to this, I will see that my initial page is still hello world. And now what I need to do is if I go to capitalize and give it an input, which is, let's say, hello, the output is going to be hello, but with H capitalized, which is what the capitalize function is doing. So this is a very, very basic example of how you can have dynamic roots. So instead of this, if I now say tinyml, then I'm going to have tinyml, but T becomes capital, everything else becomes small, which is what the capitalize function is exactly doing. And this is an example of a dynamic root. Yeah, let's now take this a little further. Let's try and multiply two numbers, and that will be the last example that I will do before we switch to HTML pages. So what do I need to do? I need to once again define a root, and this time we are going to say multiply, and we're going to take two variables in here. So I'm going to say that basically put two integers. So int can be n1 and then int n2. I'm going to define a multiply function that's going to take these two as input and basically return what am I going to put here? I'm going to put this, and this is going to be the product. You can have some, you can have anything that you like, really. My apologies, I keep doing this. Yeah, so now basically we have a multiply root, which is going to take two integers, and if you hit that root, hopefully this is now going to return rendered HTML with string corresponding to the product of the two numbers. By the way, in case you're wondering what these numbers are, these are response codes. Anything beginning with a 2 tells you that things are looking promising. You can look up error codes. HTTP response codes beginning with 4s and 5s are usually indicative of problems. You should look up API response codes to understand them. But when the server responds to a GET request properly, you get these kind of response codes. So what I will do is I will stop this from running, and I will kill my Flask application here. This runs now, and I can just go here, and I can say 2 and 3, and that does not work because I have to put a multiply before this, and it gives me the product, which is basically what I've done. Nothing impressive, but this is the basics of running a Flask application. Let's go one step further. Let's try and put an HTML page now into our Flask program and have Python host that. So what we will do is we will call this root index. So basically, these are all now roots that are running, and adding new ones still keeps the old one. So now you have all these roots basically within this main root. So what we're now going to do is we're going to add a root called index, into which we're going to put an HTML file. So I will say index. And what I will do now is I will say index. And here, what I'm going to return is going to be this render template module. So what this is going to do is it's going to take an HTML and it's going to render this for me to my front end. Now, by default, Flask looks for HTML files in the templates directory within the directory from which you're running your program. So this HTML file needs to be placed there. And if I like, I can add variable names as placeholders and have them rendered, but we'll come to that in a minute. So what I will do is I will stop this and I will make sure that nothing is running on my server here. That looks good. So now to have this work, I have to build some sort of HTML file within the templates folder. So what I can do is I can just say templates and I can go to templates and I can create an HTML file here, which I will have to open now and populate. What I will do is I will make my life easy. I will just use VS Code's inbuilt functions here to help me build some sort of HTML that, well, yeah. We don't need this. What I will do is I will add an tag which says, welcome to my first attempt at running Flask. Cool. So now this is in the templates folder. I've created this HTML file. And now if I go back and run this program, if everything was done correctly, then this should work. Let's have a look. This is now running. So I have to go here and then go to index, and then we will see what happens. There we go. So this is how an HTML gets rendered. Now, if you want Flask to be able to talk to the HTML file, which is basically what a web framework is supposed to do, what I can do is I can add some stuff here. So let me add an h2 tag and let me put some sort of a template. And here I can say variable name. If I do this, what I'm required to do is pass this in here. So I can say variable name is, for instance, tinyml. What is rather annoying if you use the same port is that you have to keep repeating this and you will have to bear with me. So now if I run my program and I go back to my server here and I go to index, what I will see is, of course, everything that I rendered, but also tinyml that is now passed from my program to the HTML file. And this is basically what I wanted to show you. So with this, now if I go back to my program, just to summarize, we talked about roots, how we can add dynamic roots by using variables, how we can render an HTML file and pass input to it from the program. Let's now stop with the basics and let's go a step further and see what we can do. Because A, I'm running out of time, and B, we have to move to something a little bit more substantial. So what we can now do is we can see, and this I will actually not write from scratch. I will just show you. So let us say we have an HTML file which simply has this kind of a body, and you have enter name. And what I want is after you enter your name, it allows you to submit, and then it does something. But what it does is going to be defined by the Python program using Flask. So what I'm going to do is I'm going to define a login page, and this is going to basically take get and post requests, and I'm going to look for this tag, the HTML file here, and based on what I get, I'm going to simply say welcome along with that input. So depending on whatever I pass in and hit submit, it is going to redirect me back to this URL, the success page. And this is a dynamic route, as we just discussed. So based on what I get, we're going to use the URL_for function. Good coding practice is to always look them up, see how they are used, how each of the functions is used. This generates a URL to the given endpoint. So this is basically going to redirect you to this endpoint. Previously, what we did was we communicated from the program to the HTML file. Now we are doing it the other way around. So this is basically going to simply run here on our local host. And from the HTML file, we are going to get the data from our port, from our endpoint. And this is basically the other way that you can use Flask. And here, all I have to do is have the program running. And when I try and open the HTML file, it should directly hit this endpoint with a post request or a get request, depending on what I send. And then it should return welcome and so and so. You can, of course, look this up. So there are, once again, just to reiterate, there is a login page and there is a success page, and this is basically what is happening. So if I run this now, this is going to run here. And now the HTML file is going to hit this endpoint. So what I can do is I can copy my HTML file. The shared folder, and hopefully any ML, and I say submit, it'll say welcome and then tiny. And if I say something else, it'll say welcome and that. And that is basically how you can use Flask to communicate with an HTML page and build very simple web apps. What was today's topic again? Machine learning. So now it's time to use Flask to do something with machine learning. Are you following? Is everything clear? Please say something in the chat window. Are there questions? Is everything understandable? I will not continue till you say something. Is everything clear? Thank you, Anu. Anybody else? Is everything clear? Any questions? Any specific requests? So what I will now do is I will try and build something for the iris dataset really quickly, and then we will extend this to what Anu did yesterday. Again, are there questions? Is everything understandable? Yeah, thank you. Yeah, so these events and their success basically depend on how you communicate and how you follow along. So please help me help you by communicating, asking questions, telling me if it's not clear. All right. Let's look at this really quickly. So I'm going to assume that I have been able to load the iris dataset. in case you're wondering, the iris dataset is a flower dataset. There are 3 kinds of iris flowers. The aim of today's presentation is to actually build API endpoints. So we're not going to talk about the iris dataset. We've just imported the iris dataset, and I've quickly fitted the model, a logistic regression model, and then I've dumped the model into a pickle file. And this is what is important. You have to make a serialized object before you build front-end applications. And in my case here, this is a pickle file. And I've basically built this pickle file. And now I'm going to use this pickle file to make an API. And then I'm going to test the API and see how that works. So here is basically how the API is going to look. So let's go through this really quickly, and then for Anu's dataset, maybe I will write this from scratch. So what we're going to do is we're going to look at the Flask libraries that we need. We're going to take Flask, and then from RESTful, Flask_RESTful, which is basically the REST API submodule for Flask. We're going to import API, a resource, and a request parsing module. Why request parsing module? Well, the endpoint, the machine learning endpoint is of course going to get your data and is going to then make a prediction, right? So similar to how we use the Flask constructor before, you're going to do that here, and then you're going to define an API object as well. I have to define my machine learning model, which is basically going to be this pickle file loaded and then opened. I'm going to define a class within which I'm going to have this post function. And I'm going to then get this request parser here. And to the parser, I'm going to add all the arguments that I need for my model. So if we go back here, you will see that iris data was what the dataset was, what the machine learning model was trained on. And so basically, my goal here is to use the trained model and give it new parameters and see what kind of prediction you get back. And this is our idea here. So once this is done, I can print my arguments to the screen, see how that looks. And then I'm going to construct a data frame from it and then make a prediction using the data that I passed in here. And I'm going to have this returned. And this is what my post function is doing. And this is going to run here. And of course, I can define my host and my port. There's a Flask debug mode. So this is how a typical Flask application looks for a hello world machine learning application. In a real example, you will of course have more arguments, and then you can see how things actually work. But here, this is basically what we have. Is using Python, pandas, and scikit-learn efficient enough? Could be used? Yeah, of course. I mean, this is not a truly scalable application at all. This is just focusing on the basics of developing a web app, specifically using Python and Flask. As for pandas and scikit-learn, well, that's your wish. You can very well not use pandas. For example, there are commented lines here where you can use NumPy. Basically, you just have to parse the argument, properly, and then pass it to your API endpoint. And concerning scikit-learn, no, of course you don't have to use it. You can use TensorFlow, you can use whatever you want. Anu used TensorFlow yesterday. And yeah, I'll show you in a minute how we can do that. Anu, do you want to say something?
No. Carry on. Your explanation is much better.
Cool. Thanks. Yeah. So that was basically that. I mean, there is full freedom about what tools you can use. Very simple. There's an endpoint. It requires 4 parameters. You have to give those 4 parameters. It's going to give you an output using the model that you give it. As simple as that. Everything else is your wish. Because this is a post endpoint, it's a post endpoint. I cannot test this in my browser. So I can test this either using API testing tools like Postman, Insomnia, or I can write a simple Python program. I'm going to go the Python route here. So what I need to do is I need to have this run. And when this runs, I can then send a post request from my program and I will get a prediction. So let's do just that. So I have to go to ml.api, and I'm going to run this. And this is now running here. And hopefully this is also what is put here. So basically this is the endpoint that this program will hit. And now this is running here. What is request parser? Excellent question. I'll show you when the program runs in a minute, because everything is going to get printed. So let's look at this program for a second. What is this doing? So this is the URL and this is the body. This is a JSON object. My JSON object has 4 entities. So these are key value pairs. So there are 4 keys: petal, sepal, width, petal length, sepal length, petal width, sepal width. Basically, there's a flower and there are 4 parameters based on which the model is going to tell you which kind of a flower is it. This is the iris data set. So these are the 4 parameters that this particular model has to receive in order to make a prediction, because these were the 4 parameters which was in the feature set that was used to train the model. So your body has to contain this, and this body is basically going to be passed in as a data object to the post endpoint, which has to then in turn be parsed by our program so that the machine learning model can take the input and make a prediction. So what I would do to test this is basically open a new terminal and run this program. So I will say test_post.py, and for the parameters that I passed, I get prediction 2. So 0, 1, 2 correspond to labels, which correspond to the 3 different kinds of iris flowers for the predictions. For the predictions that are based on these features, this is the output. Is this correct? Is this not? All of that depends on the model, and we are going to assume that we have a model that works. Let's, however, try to answer the previous question. What happens when I hit the endpoint? What is printed? And what was I trying to print here? So basically, this is where you can see your logs. And I said that after parsing, print my argument. So basically, what the argument parser did was create this args variable arguments, and those were printed. And as you can see, that these are printed here. So basically, what the parser does is, along with the post request, the input that is obtained, this module simply parses this into your Python program. It's as simple as that. That is what the request parser is doing. You can, of course, read it from the horse's mouth. It enables adding and passing of multiple arguments. But basically, you need this to get this, from which I've created a pandas data frame. I don't have to create a pandas data frame, but I just did that, and then I passed it into my model. And that is actually it. And this then returns this object. So, of course, needless to say, if I change this, then one would hope that I get a different prediction, which I do, which basically means that the program is doing something. It's basically taking this and spitting something out. And this is basically a very simple machine learning API. Let's go one step further before we switch to building an API for Anu's model. What else can I do? Assuming that I have been able to now make an API, I'm able to now read in my model, what else can I do? So what I will do is I will, So now let's look at this, and I have my pickle file here in this directory, the same place where I've got my app.py, and I've got my templates, which has my index.html. So basically, there's no need to reinvent the wheel. And so I'm not going to write this HTML file from scratch. But basically what this is doing, and I'm going to talk through this, is that these are just to make it look good. You don't need this. You don't need a CSS file. You don't need anything. The only thing that I really need is this URL for, which I talked about. And this is going to go to the predict route, which I'm going to show you in a minute. And you have to have some input boxes where you can put in parameters and then have something of type submit, which can act as a button, and the button will be labeled predict. So basically, I want to have a website that is going to have my variables that I need, where I can put in values and get a prediction. Now, what's going to happen? Once I put in my values here, I would want and expect some kind of response from my model. So these values have to now go to my model, and that is where Flask comes into the picture. We talked about render template. I'm going to use render template and render this index.html. So when I now run this program, this web page is going to be hosted by Python. Then I'm going to have a predict route to which I had a redirect URL, if you remember. And then what is this predict function going to do? Similar to what I showed you in the API, this is simply going to take my features from request instead of argument pass. Now it will take it from form. What is form? Well, that is basically coming from here, from your HTML page. And these are just placeholders that you're going to see in the HTML page, which you have to replace with your real values. So, and then you're going to get a prediction, and that prediction is going to be passed back in place of prediction text. So if we look here, you will see that you're going to get a prediction text. Prediction text. And that prediction text is going to be the placeholder similar to what I showed you earlier, where I coded from scratch. This is a placeholder, and this is going to be passed in from our program. If this is not clear, please ask me questions. It's actually very, very simple. It might not look that way, but the same way that you're just passing your argument requests from the post requests from the API endpoint, it's exactly the same thing. You're just taking it from your HTML page. That is it. And you're hitting the endpoint with these features. You're creating a NumPy array from the features, and that is it. Making a prediction using the features and then returning the prediction back. And so if I now run this and I open this, I will see this kind of a page, which is what I built. It looks this way simply because of the CSS that's in there, nothing else. I can basically put in numbers here, and these 4 arguments are going to be passed to the Flask program, if it's working correctly at least, and it'll give me a predicted class back as the output. And this is basically what is going on. Hopefully I'll get a different class. There we go. So this is how you can actually build a very, very simple front end using Flask and using a machine learning model. Questions? Comments, suggestions, anything? Okay, if not, all right, thank you. In which case I will continue. So now the obvious question is that we have this for iris data set. How do we do something useful with this? How do we do this? How do we use it for a real, if you give string instead of integer, absolutely no problem. You just have to parse it with the correct data type, and that's it. So in this specific case, actually, you're not passing an integer, you're passing a string. So if I look in here, and I look in here, you're actually passing in a float. So I can pass in a float, and that is how it is processed. But no, any data type works just fine. You just have to parse it correctly, and that data type has to be compatible with your model, of course. If not, you will have to convert your string into a float or into an integer. But usually, this is not a problem. The page will give you an error if you have incompatibility in data types, and you will usually see the error in your front end as well as in your logs when you actually hit the endpoint. And this is how you debug. Flask has a debug mode, and it basically prints everything out for you, and you will see that you have conflicting data types and you have to fix it. By the way, this has nothing to do with Flask. If you were to run the program just like that with conflicting data types, you'd get the same error. Flask just prints it out for you nicely when you hit the endpoint in your logs so that you can see what's going on and you can fix it. The data type and all data manipulation happens basically within your function. And the function is just rerouted to a URL or to an API endpoint, depending on how you're using it, using this app.root functionality. That's basically all that's going on here. All right. If there are more questions, comments about this, I would say please look at the GitHub repo, because I will now close this and I will go to classification dataset. We can have a look. So let's start with the API stuff. I see. So you might be wondering where the model.pkl file came from. If this is the case, I will redirect you to the GitHub repo. I think it was Anu's GitHub repo, and you can actually find the pickle file here. So these are the results of what you guys did yesterday. And you should actually use your own pickle file. But Anu was nice enough to put it here, and I stole it from here. But basically, you have to have a serialized file. You can also use joblib instead of pickle, by the way. So whatever you do, you have to produce a serialized object, and you have to then use it in your front end. So that is where the pickle file came from, in case you're wondering. For the iris model, iris dataset, I just quickly fitted a logistic regression model and got a pickle file. Here, I've taken the pickle file from elsewhere. What do I need to do to make sure that things work? I have to look at the code to understand what I need to pass in to my endpoint. So this is basically what I wanted to talk to you about. So if you look at the data, and if you look at how the model was trained, you see that there's one label, and there are basically seven parameters that are being passed in. And if you look at how the model is being trained, you will see that this is how the feature dataset is constructed with 7 columns. And of course, there is a label which can be 0 or 1. It's a classification problem. Of course, I can also do regression. But the only thing that one has to look for is to make sure that the trained model basically takes these number of features. And that's the only thing that I need, because I have to pass exactly that number of features as request arguments for it to work as an API endpoint. So once I've had a look and I've made sure that I know how many arguments I have to pass, that's all I need, because the model is created. So I have to open the model as I did, with the iris data set. So I'm not going to code this from scratch, because there isn't enough time, and also it'll become too taxing. But I will, however, talk through it once again. So I am going to open my pickle file and have this here. If not, you have to put the path, and you get your model. Just like with the iris data set, I'm going to make a predict class within which I'm going to define a method, within which in turn I'm going to have a function. Now my request parser is going to get arguments that this particular model needs. So basically now I have to pass in seven arguments. And I'm going to then basically parse them here into args and print args. To add some variety into the mix, I could have used pandas once again, but I wanted to talk about NumPy, and this addresses a question that was raised before. You can, of course, use NumPy. Basically, you have to produce some data structure that your model accepts, and that's really all that it is doing. This is a function from NumPy, which is going to help you create a one-dimensional array. What if you get this wrong? What if you forget to do this? Or what if I forget to reshape? Why am I reshaping? Okay, let's not reshape. Let's try and learn something here. So let's say that I have now created this function that is going to take these arguments that my model requires. I've parsed them. I've tried to build some kind of NumPy array from this. And now I'm saying that, just put this stuff into the model and basically print out whatever you get. I don't even know what you're printing out. So I will just print out whatever I'm getting, and I will basically see what comes. And if everything works, then return the status code and wrap it in this endpoint, and that is it. And this endpoint then has to be hit in my post request. So exactly the same thing as I did before, but 7 arguments instead of 4. And now I'm using the pickle object that was made by you people yesterday. So this is basically what we're doing. How am I going to see this in action? I have to, I have to first open a terminal and okay, cool. So now I will write a similar Python program that is going to hit the endpoint and see what comes. So what do I need to do? I need to hit this particular endpoint, which was defined here. Basically make a post request, pass in seven parameters. So I can just take some parameters from the data set and then just put them here, make some changes, no problem. Pass this in with my post request, and I'm going to print the JSON object that my endpoint returns. Everything should work perfectly, right? Let's see. Not so much. So basically it says that my JSON cannot be processed because it was expecting something, got something else, didn't work. What happened? So what I need to do is basically try and see in my logs, which is not always trivial, what really happened. Good rule of thumb is to go all the way to the top, because that's usually where the problem starts. So this was running on this HTTP endpoint here, and that is what this tells you. And then it gives you some TensorFlow stuff, and then it prints this. This S1, S2, S3 these are all strings, as you can see, and this was the result of this print args. So it very conveniently printed these args for me. After which I use the from iter method in NumPy to create this x_new, which is basically an array consisting only of these objects of the values, and I can see that too was produced without a problem. And then it gives me a TensorFlow warning. I go down, and then there was a post request, which should have given me 200 and something if everything worked, but it gives me 500, which means it doesn't work. What happened? We keep looking. So here we see that input 0 of layer dense is incompatible with the layer expected main dimensions is to found end dim equal to 1. What does this tell you? What do you think could be the problem? Once again, you see the same error being repeated. Input 0 of layer dense is incompatible with the layer. Expected this, found this. And then it decided not to do anything. And this is where we are. What do you think? How do I fix this? Exactly. So this is basically what I was trying to sort of drive home with the debug feature of Flask, and also answer your questions about incorrect data dimensions, incorrect data types, and things like that. So if your model basically expects data in a certain form, you have to give it in that form, and it'll tell you what it expects. It expects a two-dimensional data structure. So as was said here by Alan, it expects a matrix, but we gave it a one-dimensional vector, which basically means that we have to change the data structure. There are many ways to do it, but with NumPy, you can very easily use the reshape functionality and just say what dimensions you want to reshape it to. And that is basically what we are doing here. And we can then print x underscore new once again. And we can then see what happened. So we can simply save this, and then once again it's running, and I can go back here now, and I can make a post request. And now my post request actually worked. It gave me prediction 0. So basically this is the prediction that you guys did. But what is now happening is that, very simply put, it's sending these parameters from this program here to the model and getting this output. What happened here? Now we can see in the logs that first of all, you got a 200 as expected. Because now my model is happy, it's got the data structure in the way that it wants, and it's been able to process it and return my prediction to me with the status code that I told it to do if everything works. What else did it do? Well, it printed the initial data structure that I had, which is basically the result of line number 35. That didn't work, and so I reshaped it, and we see now that it's basically a nested list. So now it is a two-dimensional array, and it's no longer a one-dimensional array, and that is exactly how the model was trained, and that is basically what the model was expecting, and it's as simple as that. And once you do that, the same principle, the post request works just fine. We can change these values and it will change as well. This is established. I checked this. You can run the program and you can test it with different values and basically see how it is looking and try and make sense of your machine learning model by using an API endpoint. You can also run your endpoint on Postman or Insomnia or any other HTTP testing app and application, and basically check these endpoints that you've built. So much about API endpoints. What if I want to do the same thing that I did for Iris with this data set? And this is basically the last thing that we're going to do before we go to Streamlit. Questions, comments? All right. If not, then I will go here. Now, basically, I have templates and I have my index.html, which I'm going to open for you. I have app.py. So hopefully my thinking is now becoming clear to you. I've taken the exact same HTML file, the exact same app.py file, done exactly the same thing that I showed you for Iris now for this data set. So what has changed then? Well, only the number of data points that you have to give and nothing else. Now, instead of placeholders for Iris, I have placeholders for this data set. So what are we doing here? We have some elements here that are meant to beautify things. And And then, of course, what we're going to do is we're going to define this, which is for the CSS for beautifying. We're going to have predict class category, and then we're going to have this URL redirection with the post request just as before. This is just these input boxes that we also had for the iris dataset. We're going to have the submit button, and we're going to have the prediction text. So nothing really has changed. We're just going to have 7 boxes instead of 4 boxes, and we are going to use different placeholders. What about the Python program? Once again, nothing has changed because you're going to load your pickle file. You're going to render your HTML template. You're going to make a post request to the predict endpoint just as you would there. But for reasons that I explained in depth, you would have to reshape to make sure that your model is happy. And I'm not going to, repeat that whole thing and get the error because I think you get the drift. What am I going to do once I have a prediction? Well, I have to round it to a 0 or 1 class, which is what I'm going to do here, so that it returns. And then I'm basically going to fill this placeholder with what I get here. So I'm going to use prediction to fill this placeholder, which is in turn going to fill this placeholder when I hit the submit button. And that is basically the whole architecture. So if I now run this program, what I should see is Python hosting this HTML file, which allows me to sort of interact with my model through the HTML page, just as I showed you for the iris dataset. So let's do just that. All right, that looks like it might work. So let's give it a look. Sure enough, it now at least gives me 7 boxes. Whether it works or not is something that we have to see. Let's just quickly pass in some data and see what we get. And this now returns an output predicted class 0. And if I now look here, I will see that it actually gave me a 200 response. I haven't printed the logs here, but this is basically how this would work. Of course, now, I'm just showing you the bare bones. You can make it much more beautiful. You can put pictures on your HTML file. You can, polish the front end indefinitely. But in essence, your data hits the API endpoint, and then returns something here. And this is basically the behind the hood functioning of a web app. I think this is basically what I wanted to show you about Flask. So I will pause for a moment and take any questions about Flask routes, API endpoints, redirection of URLs, HTML integration, and the last 20 minutes is going to be about Streamlit. After that, I'm going to pause for 2 minutes and take questions.
Promit is going super cool, I guess. Promit, there's a hand raised by Abraham. Can you just maybe take up that question if he has anything?
Absolutely.
I cannot see any questions as of now. If you want to,
I also cannot see questions.
Yeah, maybe if you want to ask anything, you can definitely ask. Okay, so no questions so far.
All right, we'll give them a minute, and then we can switch to Streamlit. I'll wait for a minute for this to sink in. You can see if you can access the GitHub repo, and then we'll switch gear for our last phase.
Yeah, definitely. I hope everyone is following up. Definitely, they will be.
If you're not, please let me know, because there's no point in moving forward if you're not following things. So please do speak up. Well, I'm going to take your silence for affirmative that there are no questions, and also for the fact that you are actually following. So all right, then that's it for Flask. We're going to go here, and now we're going to move to this. And this is, by the way, also how the repo is structured, so you can follow along using the repo too. Now I will go into Streamlit, and I will quickly try and build something for the iris dataset from which we can then extend this to our nose model. So
yeah, there is a question. Can you take that up?
Yeah, one sec. I'll look at it in a minute. Do I really need to learn HTML and the rest to be good? Good time to ask this question. I was just going to introduce Streamlit. So normally, yes, but with apps like Streamlit, and there are other such apps too, you can actually leave out the HTML and the API development part and focus entirely on your models or your data analysis. It's a very quick way to bring web apps to life. And also Streamlit allows hosting. Streamlit is relatively new, so it's a library that's constantly growing. I'm a big Streamlit fan. But I have to be honest, if you want full freedom and a full understanding of what is really going on, then yes, you have to have a basic understanding of how to productionalize machine learning. But if you want to quickly see your apps in action, build a shiny front end without doing a lot of work, then no, you don't need HTML. I would also like to point out that you don't have to be super good at HTML to have a functional front end, after which you can, of course, then pass this on to somebody else. The backend part would be to just have your model, have an API, have it in a form that can be integrated into a front end. Streamlit basically does that all for you under the hood. And this is basically what we're going to look at here. So Streamlit, this is where we are. Please feel free to look Streamlit up, the fastest way to build and share data apps. And this is basically what we're going to do. Streamlit has also a very nice documentation and super interesting because you can actually see things happening real time. What I will do, for the sake of this tutorial is let me do one thing. Let me delete this file. Let's rebuild this and then let's extend this, because if I talk through already written code, the effect is not going to be the same. I hope that you will take this as invitation to code along with me. All I really have is the three PNG files corresponding to the three types of iris flowers. If you have these PNG files, that's fine. If you don't, that's fine as well. This is just to make the front end look a little bit good. And with Streamlit, you can do this without much effort. And this is the only reason I have them here. I'm going to call my file map.py because that's what it was called. Open it up and start coding. Bunch of imports. Streamlit is usually imported as ST. I need the typical data processing libraries. If I'm going to train my own data set, then of course I need the machine learning libraries. If I'm going to take somebody else's pickle file, then I don't need anything. But right now I'm going to take the iris data set from scikit-learn, so I'm going to import that. If I have to train my own model, then of course I have to import that. In this example, we can try random forest maybe. So I have to import random forest classifier. And if I want image processing to work, then I have to get the libraries for that as well. So the first API for Streamlit is the write. So st.write. I can say that this app allows me to get my basics right. And let's see what happens. If you run this, then it'll say that you can actually do Streamlit run. So we can do Streamlit run my app.py. And if I run it just in its present form and follow this network URL, interesting, and try and open this in a browser, what I should see is basically whatever I try to write. So everything that I did in Flask by having a root and all of that, as you can see, is no longer required with Streamlit. Not only is it hosting the application, it's also directly rendering my text to it. And this is, of course, happening via Streamlit's APIs, but that takes the work, away from you. And this is basically everything that you need for Streamlit really to get things right. And then everything else is on top. So hopefully this does help you get your basics right. We are going to now actually replace this with what we're building. So we're building a simple prediction app for iris dataset. Great. So we can define some image variables and have these files opened. So this is Setosa, and excuse me, this is going to be Versi Gola, and then I have to open this. It's the third kind of flower. It's Virginica. There we go. Cool. Then, if I want this these images rendered to my front end, I have to use st.image. This basically, you can read up about all of these things. What is happening? What's going on? Also, the Streamlit manual is a wonderful place to look this up. Anyway, so basically, you want your images, to your front end, and that's what you're doing. Nice thing about Streamlit, you save the file, you go in here, you refresh it, and you should have what you tried to do. And simple prediction app, and you've then got your three images that you rendered. So you can actually see your app in action here with Streamlit. Next cool thing about Streamlit is you can make it very easy for people to pass in parameters. So you can just say st, and then if you want a sidebar, then you can define a sidebar, and you can have a sidebar header, and you can say that user input parameters. And this is how the user gets to interact with your machine learning application, by knowing where to put variables and what variables. Streamlit is a Python library, so you can use all Python functionalities any which way you want. Let's define a function that will take input features and return a JSON object that we will need for our model. So what do I need? I need basically this. Then I need the width, and I need the petal length, and I also need petal width. What we can do is use sidebar, because I want this to be in the sidebar. You'll see this in a minute. And let's try and make it look nice by using the slider functionality. So you can basically slide and choose your values. What do I want this feature to be called? Let's call it sepal length. Streamlit makes life easier for you even further. You can choose a minimum value, you can choose a maximum value, and you can choose a default value. And if you do nothing, it goes with the default value. And I will simply copy and paste this. This is going to be, if you have questions, this would be a good time to ask them while I'm copy pasting stuff, so I can, look at them as well. This is going to be petal length. And finally, I'm going to have petal width. There we go. The values cannot, unfortunately, have the same limits, because that would not make sense. So I would have to put something that actually makes sense. This is going to be 3.4, and then let's say 1 to 6.9 and 1.3. Say 0.1 to
Promit, I had a question over here. We cannot have same values for this.
No, you can have, of course, but it wouldn't make sense because you. I mean, of course, you can put any value, but I mean, models work best when you put values that are meaningful because you train the model on a certain kind of data, right? So that is the only reason why I did this. From the point of view of the program running, it would work just fine if I left it as it was.
Oh, okay.
Yeah.
So that means it's not necessary to put up any values as of now. We can put it randomly.
No. So actually, you don't even have to. You can just put an empty box where the user can enter their own value. This is just to have a. You'll see in a minute. This is just to have a slider to give it a nice feel. You can also put an empty box where the user can just fill it like a form.
Okay. That will work.
I have to basically now create a data frame or create some kind of data structure. Let's hurry up a bit. So sepal length is going to be sepal length. What else? I need sepal width, which is going to be sepal width. So I'm basically defining my JSON, which is directly going to become my pandas data frame, which I'm going to render to my front end. And that is basically how we are going to get our data rendered to our front end. Petal length. And finally, we have the fourth parameter that we need for our model, and that is going to be petal. So here we have the 4 parameters. We have the data JSON structure. We can make our features data set from this. So we're going to say data. I will save you some pain. There would be an error. We would have to debug it. You have to pass index equal to 0 in this way. Otherwise, pandas is going to complain. And there's no time to go through that. But that's also not relevant to streamlit. But if I want my features data frame to be returned, I have to say index equal to 0 for this to be returned properly. And this is basically going to return my features data frame. Let's now invoke this function quickly. So I would just have to say user input features. It takes no arguments. And then we can then say that we can put a subheader maybe, and we can say user input parameters. And we can write our data frame. And that's it. Let's save this and let's see what happened here. There we go. So now this is how my thing looks, how my model looks. You can scroll down here and see your images. And you can see that this is your user input parameters. This is your index. This is your sepal length, sepal width, petal width. How did it get these values? I would like to remind you that we put certain default values. We put minimum, we put maximum, and this is what Soham was asking. So that's the only effect that this has. It allows you to define sliders. You can drag these values, and you will see that as I drag this value, the sepal length changes, the sepal width changes, the petal length changes, and so on and so forth. So it's responsive, and it's basically allowing me to change my data any which way I want. And these are the user input parameters. What do I have to do now? I have to put these user input parameters into my machine learning model, get the prediction back, and print it on the screen. And that is basically the ML web app in function. And that is it. So how do I do that? Let's go back to Visual Studio Code. I have to, of course, now train my model because I don't have a pickle file. Actually, I do from the Flask, but okay, let's quickly do so you can load the iris data set. You can define this and then define the target. Target is 0, 1, 2. Data is basically these 4 features. Let's instantiate the random forest classifier and let's proceed to fit our data. Not going to be the best model, but that is less the aim here. This is much more about getting the web app to work. So I'm going to now say this and then predict df. What is df? Df is what the user passed in from the front end. And that is it. So now you've got your prediction. We use random forest, so we can also get prediction probabilities. We're going to do that as well if you like. So you can take this and you can pass in your data frame once again. And then we can say class labels and index numbers. And then this is basically from the iris dataset. You just have to know that this is one of the keys. I mean, if you print the entire iris object, you will see what is there, what is not there. And of course, then you have to print your prediction. And that's actually everything that we need. We can also go one step further and we can say that name the prediction and then write prediction probabilities. Okay, let's actually see how far we went with this. So let's do this. So now if I go down, I will see that these are the user input parameters and it gives me an error. Set load iris has to be. Yeah, that's a lot better. So these are the user input parameters. Remember, I printed class labels and index numbers, and then I'm printing the prediction. And hopefully, if I change stuff, something is going to happen. Let's see. Good. So it changes. So basically, depending on what features I put, I can see that I'm getting some prediction. You can see that these things change. So I change this and then this changes as well. So if these are my values, then my model tells me that, hey, it's likely to be vesicular. Again, correct, not correct, accurate, not accurate. That is another story that depends on your model. And that is basically going to happen at your backend. This is about bringing the model into the web app, building a web application. And that is basically what we're doing here. What can we add to this? So let's now say we want prediction probabilities. I want to know if, any of this is making sense. Probability. And you, of course, have to write out the prediction. This was a variable, so. And last but not the least, you can even have an image rendered of your prediction. So if prediction is 0, 1, you can go back and say, I'm not going to do it, but I can say st.image setosa, whatever. So basically, if it is 0, then show me setosa. If it's 1, show me image of vesicular, and it will basically print this to your front end as well. So to go back and show this, now what do we have? We've got this. We've got the user input parameters. We've got the class labels and index numbers. We know 0 setosa, blah, blah, blah. And now we know that prediction is 0. This is setosa. Seems that the model is very confident. So your prediction probability is 1 for this. And yeah, that is basically it. And you can then change this and you can see how things change. So, you have different probabilities, so even if the class remains the same, prediction remains the same, the probabilities change and so does the user input data frame. And the entire data frame is just printed to your front end without any problem, no JSON parsing, no request parsing, no post request, nothing. And that is where Streamlit really scores over the more conventional web frameworks. All right, that was Streamlit for Iris. What we will do is we will quickly, in 5 minutes, see how we can extend this to Anu's model that she showed yesterday. And that was basically what we wanted to do. I need the pickle file. So Okay. Once again, similar to the approach with Flask, the program is identical. I have not changed anything because I did not want to complicate stuff or add anything new to the mix. You're going to write simple app to predict categories. Everything is going to work as desired. The only thing is now you need 7 parameters instead of 4. And now I'm using this number input. So instead of the slider, we'll have a little box where we can put in our values. Our data frame is now going to be composed of S1, S2, S3, and S all the way up to S7. And this is basically going to be returned and then rendered to the screen, which we will see in a minute. Then we have to get a model. Instead of training the model, I will now basically get it from the serialized object file. And this is Anu's pickle file. I'm going to take it, load it, and then get my predictions using this model and the data frame that the user created on the Streamlit front end. And then you have class labels and their corresponding index number. Makes no sense because that was for the IDIS dataset. And you can have prediction, and then you have to round them to integers, which you can do. And you can basically just run this and then see this on the front end. No, you would have to. So and there we go. And now if I come here, I see that, I have little boxes. Everything is set to 0. And I can basically do what I want. I can come here and I can put 10. I can put 10. I can put, and so on and so forth. And you will see that this changes. Yeah, and that's it. And you get a prediction label, and that's basically returned. Class label makes no sense, so I have to get rid of that. Where am I writing class labels? This makes no sense. So I can come on this line. And this is a very simple, very basic, yet functional Streamlit web app for the model that you people built. Every time you reload the page, it goes back to its default values, which is why I like having some kind of default value so that you at least have something meaningful in there. And, I like the slider as well, where you can actually, slide and make stuff. Of course, now you can go all the way. You can have different kinds of models. You can choose models from your drop downs. You can even upload your CSVs, train your model using this. So this can work as an AutoML tool as well. So can Flask, but with Streamlit, it's a lot easier to, get this done. You can, upload your data. You can train your model. You can take that model, make new predictions. So you really have a lot of freedom, and hopefully this presentation gave you a little bit of an overview of how you can productionalize machine learning and what is happening under the hood when you're actually embedding a model or taking a model and building it and doing something. This is where I will stop and take questions. Thank you very much for your attention. I will stop sharing my screen and take some questions. Thank you.
Wow, this was pretty easy actually, Promit.
Yes, that is the beauty.
We won't be we didn't require any deployment also, right? This is just the network UI that we got. We can deploy this on GitHub also, right?
Yes. So that is also very easy with Streamlit. You have a Streamlit share functionality.
Oh, okay.
Which allows you to share, and you can also deploy on GitHub. You can deploy on Heroku. You can deploy anywhere. You can also deploy with Flask, of course, but Streamlit makes it very convenient and very easy to quickly bring web apps to life and deploy them.
Yes, definitely. I just wanted to, respond to the audience about this, that these details can be taken even real time. I mean, the inputs can be taken real time, and the sensors that were displayed over there, that we already have the data set. Okay. So these can be, input embedded into the microchip controller and the processors as well. and whatever you are getting, the output can be displayed here in this way also on streamlit also. That the predictions are being varying here and there, and output can be displayed directly on the front end. So we just displayed to you 2 parts. Yesterday, we covered up all the basic modeling of this, how the model has been built up, how the training set is taken care of, how the testing set is taken care of. And today we displayed to you how it is being displayed on the front end, like how it is looking to the general audience. Okay. So tomorrow we'll be showing to you how this model is embedded into a microchip controller. Okay. Microprocessor, you can say. Okay, and the live sensors will be taken care of, and even this thing, if you have a lot of data, you have a lot of data points at your end, so you can just go ahead and put up onto the the food that you are looking at, and that will give you the results, whether if it is fresh or whether if it is spoiled. So this is a very good example to have at your end. Okay, will we be using C++ tomorrow? C++ for what exactly, Ibrahim?
Okay, meanwhile, you are asking this question, I would like also to add that actually tomorrow we will show the end-to-end process, how to build the model and how to embed it. So I invite you all guys to register for free on Newton platform in advance, because we will do practical session there. So if you will have already the access, you can do it with us step by step, and we will explain all the process from the beginning, from the data to the embedding to a microcomputer. I will share now in the chat quick link. This is the free subscription to Newton platform, so you can do it today and even to start to practice, because we have a lot of downloaded, preloaded data sets. And tomorrow you will be ready to do a practical session with us.
Definitely. So coming back to your question, Abraham, I don't think we'll be using C++ on this for the microchip controller, because we will be utilizing Newton's platform directly.
Yeah.
So that won't be that won't be requiring any coding language or anything like that. So that's the main purpose of why Newton is preferable over all the other parts as well. So you can definitely go to the link that Yulia has shared. You can create an account over there. You can follow the steps to create the account at your end, and you can definitely have a look around on the platform, and that should be good at your end.
Yeah, we will show you the same case in the like in the first day, but in details with each step. And you can find this preloaded data set on the platform, food quality data set, and you can start to practice with this to be ready for tomorrow. And tomorrow we will do with you all this process. And once again, if you have some questions, you also are very welcome to join our Slack channel. And we have here the competition channel and as well general channel, where you can ask questions to our speakers, to us, or to our data scientists. So please welcome and be ready for tomorrow. Tomorrow will be a last but also very important day. And we are expecting that after this day, you will be ready. You will be ready to build it by yourself.
Yes, definitely. Okay, there's another question from Timothy. Are we also using homework development kit? HW is stand for what? Homework kind of thing? I'm not sure. I'm just guessing. Can you just elaborate that? Oh, hardware development kit. That question can be answered maybe from Julia's side. Are we utilizing that or not? I'm not sure if we are going to utilize that. But most probably, we are only going to focus on the Newton platform majorly. And I think we'll be displaying to you the actual sensors, maybe. That will be something from Julia and
Just come tomorrow and you will see everything.
yeah, actually, that should be a suspense then.
I will keep it in secret by tomorrow.
Yeah, definitely.
Yeah, only maybe one detail that I can share with you, that we will use one of the Arduino microcontroller.
Yeah. So no spoilers alerts as of now. So we'll have to wait till tomorrow.
Yeah.
Yeah. That should be fun. Actually, it should be fun.
Yeah, I will share with you also again Slack channel right now. If you are not there, please join.
Sure. Timothy, actually, you can be a part of the Slack channel that Julia had just shared. Not just Timothy, all of you can be a part of the Slack channel, and you can get a lot of updates over there as well. Alex, me, Julia, and a couple of our team members do share a lot of updates over there on that platform. So, yeah, thank you so much for joining. Yeah. So I would request even others to join it. I am aware of a lot of people over here who have already joined it, but if someone is not joined it, so they can go ahead and join the link. Okay, that should be fun for today. Thank you so much, Promit, for displaying a lot of coding part as well. And I think most of the people have definitely followed you, and we definitely have the recording. So I think a lot of people will be utilizing it on YouTube as well, on the channels.
Yeah, exactly. We will post records on the Slack channel, on YouTube channel. So yeah. Thank you, John. Thank you, Timothy. Thank you, Promit, for amazing session today. As you promised in the beginning, it was very exciting, a lot of knowledge, new practical stuff. Thank you. And I think that a lot of people were motivated also by your background as well. So yeah, thank you. Well, I think we've done for today. We are waiting for everybody tomorrow, same time, same place. And we will do the big revolution in TinyML.
Yeah, so you will be getting the spoilers alert tomorrow itself. Yeah, thank you so much, all of you, for joining us. Have a great day.